In linear algebra, the concept of vectors and the operations with them can be extended to matrices and their operations. You can use matrices and matrix operations to solve a lot of different problems. In this video, you will see what a matrix is and some operations that can be performed on matrices. Let us start with what a matrix is. A matrix is simply a rectangular block of numbers. For example, the matrix you can see here. Each horizontal line of numbers in a matrix we call a row, so this matrix has 4 rows. Each vertical line of numbers in a matrix we call a column, so this matrix has 3 columns. Note that each column is a vector with 4 components. To denote that this matrix has 4 rows and 3 columns, we often say that A is 4 by 3 and write this as 4 cross 3. Note that we always write the number of rows first and the number of columns second. Just as for vectors, we give some special matrices their own name. One of these matrices is the zero matrix, which is an m by n matrix which contains only zeros. Here you can see a 5 by 4 zero matrix. Another special matrix is the identity matrix, which is always an n by n matrix which contains ones on its diagonal and otherwise zeros. Here you can see a 4 by 4 identity matrix. What operations can we do with matrices? Let us first go back to vectors and look at one of their operations. As you have seen before, you can take 2 vectors with the same number of components and add these, as you can see here. The new vector has as components the sum of the components of the original 2 vectors. For matrices, we do exactly the same. Take 2 matrices A and B, which should have the exact same number of rows and columns. You add these matrices to form the matrix A plus B, which has the same size as A and B. You obtain the values in A plus B by adding each entry separately. So the value of A plus B in the first row and first column becomes 1. And the value of A plus B in the first row and second column becomes 7. And these are the other values. We call this operation matrix addition. Adding matrices of different sizes is not allowed, so these 2 matrices you cannot add. Another operation you have seen for vectors is the multiplication of a vector by a scalar. Remember that a scalar is just a single number. The new vector has as components the components of the original vector multiplied by the scalar. You can also multiply a matrix A by a scalar R. The scalar multiple of A by R is the matrix RA, where each entry of A has been multiplied by R. So the value of RA in the first row and first column becomes 3. And the value of RA in the first row and second column becomes 24. And these are the other values. We call this operation scalar multiplication. Note that we write the scalar R in front of the matrix and not behind it. As you know, there are several rules of calculations for adding and scalar multiplying vectors. For matrices, we have exactly the same rules. For example, the order of addition does not matter. There are more rules, which you can see here. Besides adding matrices and multiplying scalars and matrices, there are 2 other operations for matrices, namely multiplying 2 matrices and transposing a matrix. We will consider multiplying 2 matrices at a different time, but I do want to show you what transposing a matrix is. This is the definition of how we write the transpose of a matrix and what the new matrix is that comes out of this operation. As you can read, the new matrix, called A transposed for short, has as its columns the rows of the matrix in the same order. So if we would take this 2 by 3 matrix A, the transpose of A is a new 3 by 2 matrix. The first row of A becomes the first column of A transposed. And the second row of A becomes the second column of A transposed. There are, of course, also calculation rules for transposing a matrix. and definitely if we also combine it with addition and scalar multiplication of matrices. This theorem shows the rules we then obtain. Can you see why these rules are correct? Now you know what the operations adding, scalar multiplying and transposing matrices are. We can focus our attention to the multiplication of two matrices. But that is for another moment, so you still have to have a little patience. See you next time.